Ready.
Hello, hello. Is it a product design or infrastructure design? I heard that at FP especially, they call it out, right? Saying this is a product design and
The
infrastructure
system
design.
design.
Okay, okay.
Yeah, but then you could use it for product also.
I see.
Okay,
I
so
see.
let me just walk through.
Okay.
So during the system design, we generally have problems given like design a web crawler, design a world patching system, design a WhatsApp messenger or something of that sort, right? So we are very good at designing those boxes that we need a load balancer, we need Kafka, we need scaling, we need XYZ. We'll set up auto scaling. So we're good at that. We're learning, practicing those things. But if the interviewer goes into a little detail saying that, okay, can you estimate at what point do I need to scale my nodes, right? You say that it's an auto scale system. Whenever there is a peak, there is more load, we'll scale a system. How do we determine at what point do we want to scale a system? What is the maximum one of my machines can take, right? And decide, okay, that will give us that, okay, do I need 100 machines for my use case or do I need 5,000 machines, right? So based on that, some capacity planning can be done. That's the simpler version. Now you also have to think about, we talk about globally distributed system, right? So when you scale, how would you scale your systems across what data centers would you want to scale? So things can go deeper as the interviewer starts asking questions. So one of the things I understand that there was a web crawler kind of use case given and was asked to design a system. So the person designed the system, and that's when the interviewer said that, okay, now how do you know that I can crawl 500 million URLs, which is my target, within 24 hours? Okay, so how do you go about estimating those numbers? Now, if he says that, okay, 24 hours good enough, my requirement today is let's crawl the same 500 million URLs in 18 hours. So what do you do? Do you add more machines or do you scale up? That means you increase the power of a machine. What is the thing on your machine that is limiting it to do more work? Is it CPU? Is it memory? Or is it network? These are the generally three things. So what we could do is take the web crawler as an example, not design the system, but look at how do we want to scale this thing, or how many nodes would we need, how much one machine can do. Okay. Any questions so far? Okay, let's go ahead. So here is some stats. We need to design a web crawler. The number of URLs, to scan is 500 million. One second. File size, the HTML size that you want to download is 100 KB. The time limit is within 24 hours, you should be able to scan and crawl these 500 million URLs. And the machine spec that is given is you have a dual core machine, which has 16 GB memory and 1 Gbps per second network port. Okay. Looking at some of the information from GCP, the egress of each VM can be 7 GB per second. Egress is how much data it can send out per second is 7 GB. Ingress is 20 GB. That means how much data can it pull in? That means upload and download. Think of it in simple terms. Okay. These are some latencies which have been shared on Azure Network. So this will help us distributing our nodes across the globe. So US East to Central US is 32 milliseconds. But if you go to US East to Africa, it's 220 milliseconds. Okay. Similarly, US West to Central is 26 milliseconds. And if you go US West to Japan is 106, Africa is 280. Generally, You go to Africa from any place, it's a little expensive. They're not good, I believe, fiber optic cables and stuff out there. East Asia to Southeast Asia is 34 milliseconds. So if you have a data center in East Asia to make requests to all of Asia, should be within 50 milliseconds. Similarly, if you have a data center in Europe to Germany, it's 29 milliseconds. So theoretically, what you should have is have one data center in central US, which has about 32 milliseconds to the East Coast and about 26 seconds to the West Coast. So this will cover your US region, most of it, if you take central US. If you have East Asia, this will cover your Asia APAC region, basically. So that's about less than 50 seconds, 50 milliseconds. Europe, if you have one of the data centers spread out on Europe, it's again less than 50 milliseconds. So assuming that the 500 million URLs is spread across the world and not specific to website in the US, what you would want is to have 3 data centers. Now, if you say that, okay, I don't want to have a data center in the East Coast and sorry, not in the Asia region, then just look at this number. Making a request from East to India is about 210 milliseconds latency, right? Which is what? About 6 times if you have in the East Coast, in the Asia region. So that means you can make 6 extra URLs request if your data center is in the East, in Asia, rather than in the East Coast or US. So let's do some maths. I have not done this thing. So if it is wrong, let me know. Okay. So what we would have is every CPU core allows us to create 2 threads. Is 2 threads. So that's, if it's a dual core, that means we have 4 threads running. So 4 worker jobs. Now, if you assume that one thread takes about 50 milliseconds, or let's say 100 milliseconds to download one URL, that means about 32 to 40 milliseconds goes just to go to the server to get the HTML, and 60 milliseconds is, let's assume, is the processing time. So it can process one URL in 100 milliseconds. Okay, so within 1 second, you have 10 URLs, right, per thread. Everyone with me so far?
So there is a question like whether this latency is RTP latency or like one way, I mean, round trip latency.
I believe it is a round trip latency.
Yeah,
but
okay.
we can check this URL. I can share this. Okay. Yeah, if it is one way, then obviously the numbers will become half. Yeah, exactly. Yeah, so if you have 4 threads, okay. 4 threads.
Why is it one CPU core, 2 threads? What is that?
That is what I've read, saying that you can create 2 threads per CPU core if you have multi-threading enabled.
Mm-hmm. I mean, it doesn't depends on the core, I guess.
Yeah, so one CPU is 2 threads, dual is 4, so 40 URLs per machine, right? Because I'm multiplying it with 40 URLs, right?
So Java thread is the same thing, or is it different? Like, it's the same, I believe, right?
Yeah, so my understanding is you could create multiple threads in Java, but at the time only 2 threads per CPU could run at parallel, rest everything is you need to do context switching, and they will be waiting for the main thread.
I see. No, but I see people create like hundreds of threads and
Right. But are all the hundreds of threads running in parallel, or the CPU um, kind
so
of
you mean
queues
CPU
those
bound?
thread at a time?
I
There's
see.
a
So you're
context switch.
saying CPU bound, they can only if the thread is CPU bound workload, right? If it is doing, then you're saying that there can only be like two such threads running per CPU.
Right.
Okay, I see. Okay, sure.
So this is
Yeah, but our workload is not CPU bound. We are network bound. We can create more, let's say Java thread per one core. Yeah, let's say 10, because most of time they will just wait for network and do nothing.
right. So it is very difficult to estimate of how many thread will actively be working, right? So what we're trying to do is, let's take a simple calculation and see where we can add more threads, or where our logic is not right for the calculation. Okay, the thing is, if we say let's create 80 threads, right, within a 40 let's say this is 2 threads, right? Let's say we create 10 threads, but at a time only 2 threads is CPU bound. The 8 threads are waiting, right? They could be waiting for CPU, they could be waiting for network, they could be waiting for something else. But at a time it's 2 threads, right? So let's walk through this thing, and then we could obviously change things, and we will have to take some action item to understand more things, right? Oops, where did I go? So it's 40 URL per second. This looks pretty low, right? Now, if we look at 100 KB is per URL, so what is the load? It's about 4 MB per second is the load. So that means we are not bound by network, we are not bound by memory, because we have 16 GB of memory, we have 1 Gbps port, right? Now, if you multiply 40 multiply by 3600 multiply by 24 is what we will get per hour, per day, right? So this is about 3.4 million URLs per day for a machine which is dual core. So if you have 500 million, so you would need about 144 machines to scan 500 million URLs within a day.
So this type of calculation, is it feasible to do it in interview like this?
So
This is detailed calculation, right?
But then the
yeah,
understanding is good. I mean, like, if you have this understanding, if you're thorough with these calculations, so right now if you're doing it for the very first time, it might take time, but then if you are pretty comfortable with it, so it shouldn't take hardly more than a minute, right? If you
I
have
think
all these numbers, like, instead of getting through all these numbers, if you like have a rough idea of that it takes 3 milliseconds for 200 kilometers, so you can give a rough estimate, right? For a message, like, the round trip time.
I think for the senior post, this kind of questions can come in the interview, but probably if you are going for a medium level position, SG2 or 3, probably they don't ask you this kind of details. But for senior post, probably they
This
want
might be
to.
for production engineer and not software engineer. I think
So
whoever got asked
the
this
thing
question
is,
can
if
clarify.
you want to be a technical head or engineering manager, so on that time, many people will work under you, and that time you have to know everything, right? So
Exactly.
So I think that's the only reason they actually ask this kind of question, because when you are applying for SDE 2 or 3, the only thing they want to see that if you can design a scalable system. So their focus is what kind of components you are using in the system. So that time the focus is different. But when you are going for a TA or EM, this kind of positions, that time they know that you know how to build those stuffs, all those, you know the details of those components. But what important is if you know the time limits and other factors, like how we can reduce the latency, what is the key factors there, because for the senior positions, you can just say that we'll use cache to improve the latency, because you have to know the calculations as well. And I think that's why he got this kind of questions in the interview.
I agree. And just to add to that, it is basically, how do you differentiate yourself, right? If you're at a senior level and somebody asks you about this, you cannot say that, oh, I don't know anything about CPU, memory, and network, because it's taken care by production engineers, right? It might be the responsibility of some production engineer, but you need to know these things, right? At least at a high level. When somebody's talking, it's good to know these terms, right? So just to take an example. Now, if it takes 144 machines, and somebody says that, hey, 144 machines is a lot. How can we improve this thing, right? So we could always say that, okay, instead of dual core, if you give me quad core, your number of threads goes to 8, and this number goes to 72, right? So with 72 machines, a little extra power, you can complete this job within 1 day, right? Or somebody might say that, hey, 24 hours is too much. How can we bring this to 18 hours? So you need to know what lever to turn so that your system can speed up.
Right.
Yeah.
Right. So in case of
it's a
18
good to
hours,
know.
like, yeah. So in case of 18 hours, like, what do we need to do?
So what we have is 24 hours, right? What we did was
Yes, all the calculations are for 24 hours. Correct.
now all you need to do is 18 hours, right?
Yeah.
So in 18 hours, I can do
But
only these
only
many
when you
URLs.
So I
have
think the number
worked
of
on,
machines will increase.
Exactly. So let's say you say it jumped to 192, right? So from 144, it jumped to 192 because you reduce the time by 25%, right? You remove 6 hours, 25% of the time. That's why your machine jumped from 144 to 192 hours, 192 machines.
Right.
Yeah, somebody could say, hey, machines is not a problem. Take as many machines as you want, but give it to me within 12 hours or 18 hours. This is a critical task. I want all the URLs to be scanned within 18 hours. Okay, fine. Give me 200 machines and we could do it.
So, but cost
Again,
will be
but think of it from the point of big companies like Facebook, Amazon, Google. 200 machines is not a lot. The other thing to consider is 200 machines are the frontier machines, which is going and getting the data. There is a lot of other machines in the system, right? So those you might not need so many, but these are the heavy load machines which is going and getting requests and stuff. Right? And think of it, if you have to spawn 200 ECS instances, it's not too much, right? They do their job in 18 hours and that's it. End of story.
Yeah, nice point. Good.
generally these estimates, only when you have worked on a similar kind of a system, you would know. But otherwise, it's a rough estimate, like how much time it would take typically for getting a URL. And based
No,
on
I
that,
don't
you
think it is rough. It is predictable, isn't it? I mean, we want to like model the system before deploying
yeah.
it,
So
so that it's
the
not like we
interview,
deploy
if you
it, fail,
don't,
and
if you
then
haven't in interview, if you haven't worked on a similar system, you assume that okay, a URL takes 100 milliseconds. It's an
Okay.
assumption. And then we do the estimate of the number of missions based on that.
Yeah, so
Okay.
you could start with that, and then, so let's say you, instead of 100 milliseconds, we had assumed 200 milliseconds, or I think I assume 50 milliseconds, 100 milliseconds, right? Instead of that, if you assume 200 milliseconds, your number would go from, say, 200 to 400, right? But at least your thinking process is there, right? Through the whole calculation, your numbers can tweak. Are you able
Correct.
to think through
Correct.
the process is
Yes.
what is important.
Yeah. Right. That's correct. You have to know how much processing time it would take to go over all the URLs and then able to do the crawling part. Yeah.
Right. Now, like somebody was saying, these are CPU bound, right? And 40 URL per second is a very less when we talk about like millions of reads and writes that happen. This is very less. So you could also say that we could have more threads, right? Which are waiting on the network, and the rest of the threads are working on the CPU, right? So you could have async kind of network communications is async, where a thread says that get me the data, and it goes into a sleep mode to say, while the CPU takes care of the next thread request. So in that case, this 40 can go up. But to be honest, I don't have the data to justify that. Should it be 40 or should it be 80, right? 40 is sleeping for network or waiting async for network, and 40 is actually worked by CPU, right? So if we investigate a little bit more, we might be able to get this even more accurate.
I think whatever you discuss thread thing till now, this is for the downloading all the files, right? On the DC front end. The backend also you can have different thread to processing and updating database. All these things you have to take care of differently, right?
Oh yeah, I agree. So that's what I said. So this is just the frontier server, which is the heavy work because it's
Okay.
going out, right? At the back end, everything is within the data center, right? Your databases are in the data center, your cache is in the data center. So the biggest problem is these latencies that are there. Within the data center, you wouldn't have these latencies, right? So that would be much faster. So these are just estimates for the frontier servers.
Yeah. Right, yeah.
Uh,
So this,
Yeah, this is the actually main bottleneck for downloading all the network interface thread, right? Is main bottleneck. So which you need to be taken care of first. Then in the back end, everything is coming in this one system. Then you can process very fast without external dependency.
exactly. And for those, we won't need so many machines, right?
Yeah.
It's
Yeah.
like the 80-20 rule, right? Your 80% of your machines is taken by this 20% of the work. Rest, when things come in-house, you have more flexibility. When you have to go out, dependency, then it is something you have to look at.
Yeah, good point. 80-20, yeah. In caching also, we are using same 80-20 ratio, right?
Yeah, it's a global principle that you do. Your 80% of your problem comes with 20% of the code, or bugs come with it, that kind of thing.
Yeah.
can I ask?
So I have a question on that. So in the interview, in this where these questions are asked, so does the interviewer expect us to like have this general idea about the values, like the processing time, as you think, considered
Not
as a
very
whole?
accurate, at least a ballpark, right? At least a ballpark. And then it's like we do in school, right? Mathematics. The
Right.
answer is not required, your steps are required.
Right.
The same
Okay.
thing.
So
The last accurate answer is not required.
understood. But so how did you like get to come around that value, like processing time is 100 milliseconds, like considering the latency time also, like
Right. So 32 milliseconds is the standard latency I took. From
right,
central US to go to east is 32, to the west is 26, right? So
right,
70 millisecond is what I took as the latency for reading from the network and writing into your database, disk, whatever.
Okay.
So the work required by the thread once the data is received before and after is 70 milliseconds is what I was saying.
Can I ask?
Sure.
So we have different ports. So let's say we have multiple ports. So threads, more threads will increase. I mean, more threads will increase the burden, or will like so. Every thread has to check for every port. Is this a scenario in which our performance can be affected?
So let me just repeat what you said and let me know if I understood incorrectly. So
No.
if we increase the
So
number of, so what you're asking is if you increase the number of threads, you will be waiting more on the network rather than the CPU, right? Is that what you're asking?
no. So let's say we have our 10 ports, and we have one thread right now.
Okay.
Let's say we increase threads to 4, and
Okay.
so now each thread has to check for the ports, right? Is I right?
But then there is only one port, isn't it?
Right.
Let's say if there are multiple ports, then performance, I think performance can be affected.
For
So
multiple ports, you will get more network bandwidth, isn't it? So for commodity hardwares, I think it's generally one port, one NIC is there.
So what you're talking about is
Actually,
the
this
situation
machine
where
are-
we are restricted by network. In this case, we are not restricted by network because you see the network is only 4 MB per second, right? And our egress and ingress is 20 GB and 7 GB. 20 GB is the limit we can do. And we are just reaching 4 MB. Where network will come is here, when you have patch the world kind of situation, where your patch size is 4 GB, your number of machines is 100 million machines, or let's say billion machines that you want to patch. That is where you will hit this limit, because now you're not doing ingress, you're doing egress. That means your installer, patch installer is going out. That means you cannot send more than one patch per second, right? Because 7 GB is the limit. So in that case, your system design will come into picture where you say that you are not using the hard disk or the network of the machines which are doing patches. You are putting it onto a NAS storage or S3 kind of thing, where multiple machines can download at the same time, right? Then you're not restricted by the network port or the egress and ingress that's provided by the cloud, right? So I have not gone through this. What I would think will be helpful is we actually design the system and say that, okay, how will patch of the world work, right? If you have to download 100 million machines have to download a 4 GB patch, would they go to the machines which is pushing the patch, or would we have this patch deployed onto a S3 kind of place or CDNs where it gets quickly downloaded, right? That means your machines are not under too much load.
No, but then either ways, the machine will be under load. Suppose you talk about a CDN, even CDN is part of your system, correct? Maybe it is third party, but then as the number says, egress is 7 GBs per second, correct?
That is on the VMs.
And for this CDN, we assume there
CDN,
are multiple NICs, right? So that will increase proportionately.
You're right.
Okay.
Yeah, so this is a little more complex in the sense we cannot do a simple math. We'll have to actually design the system and see that where the bottlenecks are. Does CDN make sense? It is 4 GB. What
Here
happens
you
if it
talk
becomes
about
40 GB?
distributed storage system, right? Here
Can you
you
repeat
think
that?
about distributed storage system, right? To
Yeah.
keep the patch and which is a nearby storage system and you can access quickly. So
Right.
you have to think about in that angle.
Yeah. And to think of it, these are very common problems. We don't think daily, right? We're
Right.
using a Mac, patch gets distributed to millions or hundreds of millions of Macs, right? Windows, your iPhones, your Android phones, a huge number of patches, or Chromebooks, huge number of.
I'm not able to hear you.
What part did you hear last?
I
Last
think we
was
can
like
hear you fine. I have a question. How will these numbers change if we, let's say, use event loop like in Node.js or let's say Go routine or something, right?
Yes. So a
Where
lot of it depends. Is your work CPU heavy or network heavy? Fortunately, in our case, it's not CPU heavy, right? You just have to get the HTML, write it into the disk or database, whatever, right?
but we are still
Now,
allocating 60 milliseconds for that part, right?
yes, but the number of threads can be a little more. Now we have said 40, how many? 40 threads, right?
Correct.
No, four threads. Sorry, we have said 4 threads, right? You could obviously create 10 threads, but it would need a little experimentation to say that is 10 thread good for Node.js, Go, because they are very, very optimized, Go and Rust, these kind of languages.
Right.
They might be able to do things faster on the network, and then the context switching might be much faster. The other thing is important is multi-threading enabled on these machines. So this number is purely on CPU threads. As we use languages, definitely can be optimized.
Okay, sure.
Yeah, so all of this started because I was looking at the system designs and I was not clear on how to do these calculations. And that's where we started a thread yesterday on Discord. And we thought that, okay, let's have a session where we could just walk through this so that everybody gets a general idea. We don't have to be experts, but general idea how it works. I think this is something that we would need to design a system and then calculate that how many machines would it need if you have to patch 1 billion Android phones, right? So we could look at that too sometime.
So can we do it now? Just patch the word.
It's going to take more than 40 minutes, to be honest. And I have to rush to a meeting. Sorry.
Okay, no problem.
If somebody wants to take this, I can help with inputs, but I will have to drop in between them. That's all.
So can you discuss this thing in another session? Is it fine?
Sorry, can you repeat that?
This patch calculation.
Calculation, that's what I'm saying. We'll have to design the system. We'll have to see that how big are the patch size? Does it make sense to put it onto the CDNs? Does it make sense to put it on the file system? Or if the patch size is say like 100 KB, does it just make sense to keep it on the machines itself, right? We'll have to think about, is it always a push kind of patch or is it a pull kind of patch where a client is sitting on your devices and it is pulling it, right? Or do we have to think of it as a push where the machines or server says that, hey, patch is ready, I'm going to push it at at 9 p.m. kind of thing. So
are you saying that, I mean, putting on the CDN, so you will not calculate that, the CDN requirement?
Yeah, we could
and
do
we
that.
Can make, okay, okay. So then how is different than where we are putting that patch?
Right. So what I'm trying to say is we will have to play with this patch size from 100 KB to 4 GB to 400 GB, so that in the interview somebody says, hey, patch your iPhones, which is 230 MB of size, how will your design change, right? Or somebody says 100 KB of patch, how will your design change, right? So we could just walk through those 2 or 3 scenarios with calculation and design. So we know that, okay, if somebody says do this, we are confident about it.
Okay, but if the requirement is that calculate the bandwidth requirement for whether it's irrespective of whether it's a you are using your in-house or putting on the CDN.
Right. So we did do the bandwidth calculation out here. It's like 4 MB per second is what we would need. And like you're saying, depending on the path size and where you're putting it, we can always calculate the bandwidth requirements.
Okay.
It is not equivalent to that Netflix streaming type of thing. Netflix or
could be similar, but the thing is with Netflix streaming, you have to do a lot of compression. You have to do a lot of device types, right? Those things. In this, you don't have to do different type of compressions, right? You just compress it into one single format. You don't have to look at different device types. So if you're giving a patch on Windows, it's on all Windows laptops or desktops, right?
Agree, yeah.
Moreover, it will be compressed.
Yeah, it is already compressed. You don't have to categorize based on the device type.
Yeah, so we can take certain pointers from there, but we can't pick a lot of things from it. But if you have a link for how much bandwidth and stuff is required by Netflix, that will also be a good read for everyone. Does this sound good? Does somebody wants to take this now, or do you want to do this some other day?
Let's do it on Friday together.
Give me 1 second. Friday the same time, 9:40.
Yeah.
Okay, I am good for Friday. Yeah, let's do it on Friday then. I will share this document so that people can add edit as they would like. If you think of any other use case which has a similar requirement, let's add it so that we know that, okay, this template can be applied for other similar use cases kind of thing. I will